Hello and welcome. In this video, we're going to be discussing how to divide a polynomial by a monomial. But before we begin with this problem, let's recall a couple of facts that we learned earlier. So the first one is how you add fractions with the same denominator. So if I add 3/11 plus 2/11, note that in my answer, my denominator is going to stay the common denominator, which is 11. And the way that I get my numerator is I just add the two numerators together. So in this case, I would have just 3 plus 2, or 5, over 11. What I want you to note about this is that if I can take two separate fractions, add them together, and combine it into one big fraction, then if I start with one big fraction, I can go backwards. I can separate that big fraction into its two component fractions. The second fact that I want you to recall has to do with dividing by like bases. So you'll notice that in example 2, I'm taking v's and I'm dividing it by other v's. I'm taking w's, I'm dividing it by other w's. So recall how we do that. We do that really by subtracting the exponents. So let's take a look at this example and how we might do that. So if you look at the v's, what I want you to notice is that I have more factors of v on the bottom than I have on the top. That means I'm going to have v's left over on the bottom. How many v's are going to be left over on the bottom? Well, that's where I subtract my exponents. So in this case, I've got 10 minus 2, which is 8. So that means I'm going to be left with v to the 8th on the bottom. So all my v's on top are going to cancel out, and I'm going to be left with v to the 8th on the bottom. If we look at the w's, well, this time I have more factors of w on the top than I have on the bottom. So if I subtract my exponents, this time I'm going to be doing 7 minus 3, leaves me with 4 factors of w left over on the top. So all my w's are going to cancel on the bottom, and I'm left with w to the 4th on top. And really, where the v squared was, I'm left with a 1 there. And where the w to the 3rd was, I'm left with a 1 there. So if I multiply my tops together, what's left of them, I have 1 times w to the 4th, which is w to the 4th. On the bottom, I have v to the 8th times 1, which is v to the 8th. So our original problem, we're doing division. So my first step is, let's turn this into a fraction. So I'm just going to rewrite as a fraction. So here I'm dividing out, I've got 5v to the 5th, w to the 5th, plus 20v to the 3rd, w squared, and I'm dividing that quantity by 15v to the 5th, w to the 5th. So here's where we're going to use that first fact that we recalled up here. This time I'm starting with one fraction where my numerators are where my numerator is the sum of two things. So what I'm going to do is I'm going to break this fraction back up into its original components. So if we look back, I'm going to break it really into this guy over this guy plus this guy over this guy. So I'm going to break it back up into its original components. That's my second step. So step 2 is break into components. So my first fraction is 5v to the 5th, w to the 5th, over 15v to the 5th, w to the 5th, plus, and then my second fraction is 20v to the 3rd, w squared, over 15 v to the 5th, w to the 5th. My next step then is I'm just going to apply the second fact that we recalled. So when I'm dividing like bases by other like bases, I'm going to subtract the exponents, and I'm really going to subtract them from wherever I had more factors of that particular base. So when we look at the first fraction, we've got 5v to the 5th, w to the 5th, over 15v to the 5th, w to the 5th. So I'm going to look at each factor separately. So when we start with the 5, well, notice I've got 5 on top, and I've got 15 on the bottom. That's a fraction that can be reduced. So I can divide top and bottom by 5, and that leaves me with a 1 on top, and then 15 divided by 5 leaves me with a 3 on the bottom. Okay, now if I look at my v's, well, notice I've got v to the 5th on top and v to the 5th on the bottom. So if I divide top and bottom by v to the 5th, all my v's are going to cancel out on the top and on the bottom, which leaves me with 1 and 1. Same thing with my w's. I've got the same number of factors of w on the top as I have on the bottom. So if I divide both top and bottom by w to the 5th, I end up with a 1 and a 1. So if we just look at the first fraction, all that's left, if I multiply the tops out, 1 times 1 times 1 is 1. 3 times 1 times 1 is 3. So I'm left with just 1/3 after I simplify. If we look at the second fraction and we simplify, well, let's start again with just the coefficients. So we've got 20 on top and 15 on the bottom. So I know 5 again is a factor of both. So I'm going to divide the top by 5. So 20 divided by 5 gives me 4. 15 divided by 5 gives me 3. Okay, if I come to my next factor, it's v. So I've got 3 factors of v on the top, and I've got 5 factors of v on the bottom. So notice here I've got more v's on the bottom than I have on the top. So that means all my top v's are going to cancel, and I'm going to be left with 5 minus 3, or 2 factors of v left over on the bottom. If I look at my w's, well, notice again I've got more w's on the bottom than I have on the top. By how many? Well, by 3. So I've got all my w's are going to cancel on the top. On the bottom, I'm left with w to the 5 minus 2, which is w to the 3rd. So if I multiply together what's left from the second fraction, well, on the top I'm left with 4 times 1, which is just 4. On the bottom, I'm left with 3 times v squared times w to the 3rd. And that is my final. Okay, now it's your turn. So pause the video, try this problem, and then come back when you've given it a shot. Alright, so let's check this one out. So our first step is, again, we want to change this into a fraction. I just want to rewrite it as a fraction. So we've got 3x to the 3rd y to the 6th minus 12x to the 7th y to the 9th, all divided by negative 4x squared y to the 5th. Okay, step 2 is we're going to break it into our component fractions. So the first guy, we've got 3x to the 3rd y to the 6th over negative 4x squared y to the 5th. The second guy, we've got minus, and then 12x to the 7th, y to the 9th, over negative 4x to the 2nd, y to the 5th. So let's simplify each fraction individually. So when we look at the first fraction, notice that I've got 3 over negative 4. There's really not much we can simplify there. The only thing we could do is we've got this minus sign on the bottom, or this negative sign on the bottom. I'm just going to move it so it's in front of the fraction. So that doesn't change the fraction's value. It's just a different way to indicate that we've got a negative overall quantity. So I'm moving the negative in front, and then we've got 3 over 4. And then if we look at the x's, notice I've got more factors of x's on the top than I have on the bottom. So that means my bottom x's are going to cancel out, and I'm left with 1. On the top, I'm left with 3 minus 2, which is 1, so x to the 1st. If we look at the y's, notice I've got more factors of y on the top than on the bottom, so my y to the 5th, when I divide top and bottom by y to the 5th, the y to the 5th on the bottom becomes 1. On the top, if I do 6 minus 5, I get y to the 1st on top. So what I'm left with is 3x to the first, y to the first, and then the bottom I just have 4 times 1 times 1. Alright, so when we look at the second fraction, notice I've got this minus sign here, and then I've got this negative on the bottom. So if just like in the first part, I can move that negative sign so that it's in front of the fraction. When I do that, I would have a minus sign right next to a negative. So those would cancel each other out, and I'd be left with a plus. Now if we simplify each of our numbers, I've got 12 on top and 4 on the bottom. Well, it turns out the greatest common factor between those numbers is 4. So the 4 becomes a 1, the 12 becomes a 3. And again, this minus sign canceled with that negative sign, so those became positive. If we look at the x's, I've got more x's on the top than on the bottom. So all my x's on the bottom are going to be canceled out, and I'm left with a 1. On the top, I'm left with x to the 7th, and then if I subtract 2 from that exponent, that leaves me with x to the 5th. Same reasoning with the y's. If I do 9 minus 5, I'm left with 4. So all my y's on the bottom are going to cancel, and I'm left with y to the 4th on the top. So now if I just write what I've got, on the top I've got 3x to the 5th, y to the 4th. On the bottom I have 1 times 1 times 1, which is 1. So really, in simplest form, I don't even need the over 1 in the second fraction. So in simplest form, I would leave my first fraction alone. So it would be minus sign in front, 3xy over 4, plus, and then the second fraction, I would just write as not even a fraction. I would just write that as 3x to the 5th, y to the 4th, because anything divided by 1 is just itself. So that's it.